Okay, hi, I am here to talk to you about phages? No, that's terrible.
Cancel. Okay. I'm gonna keep it near your face.
Um, Welcome to our discussion about phage and the isolating of phage. I am Eli Palm. My major is electrical engineering technology, and I have a minor in computer technology, and I might have one or work on one in biotechnology. In my free time, I like to read a lot of books, specifically sci-fi, fantasy. Lord of the Rings, Aragon is my personal favorite. And I'm also a gamer. I play a lot of Skyrim, first-person shooters, Halo, Kingdom Hearts, anything. And then in high school, I ran cross country, and I still do that a lot, just whenever I feel like. I actually ran the half marathon a couple months back. I enjoy any form of science. That was always my best class in high school. And I do a lot of art in my spare time. Like I make duct tape walls for my friends' birthdays and stuff. I occasionally write poems. I've made costumes before, stuff like that.
I'm Prasanna Janakiraman. I'm majoring in biological engineering with a concentration in biomolecular and cellular engineering. I'm from Dubai. I enjoy racing cars, playing video games. I enjoy adventure sports like skydiving and stuff like that. I enjoy swimming and sprinting and other outdoor activities. I spend a lot of time watching YouTube videos and playing video games generally. And I also do enjoy science. And as an engineer, I believe that I can do application-based work using science.
Now, our objective for this class was to isolate a phage and to sequence its DNA. So, first, we tried to acquire a phage from soil and water samples that we collected from various locations across campus and even more exotic places like Lake Michigan.
I collected some soil samples from the Wabash River and also from a farm a couple miles away.
Now, our goal after that was to isolate the phage. We would extract it from the soil or water sample. Unfortunately, we were unsuccessful and had to borrow another group's phage that they had managed to acquire.
Isolating the phage involves first mixing the phage in phage buffer and then extracting a certain amount of it using a filter. Yeah, as Eli mentioned, we couldn't actually acquire a certain phage which does successfully infect the bacteria that was given to us, so we ended up choosing a plate from other team's plate. Then we move on to purification of phage, which Eli explained.
Yes, to purify the phage, we did a streak test, which is you basically place a toothpick, needle, something like that, into the plaque, and then you streak across another agar plate, and you do that 3 times until it's diluted somewhat. And then you put agar and the bacteria on top and see what grows, until you get plaques of one morphology.
The objective of the streak race is what am I saying? Oh, should I mess it up?
No, that's fine.
Okay, we can probably edit that out.
I can take it out, I think.
So the objective of the streak test is to acquire a phage of single morphology, after which we continue and make something called the MTL, which is the medium titer lysate. Okay, after purification of phage, we move on to serial dilution, which involves diluting the sample over multiple times over several containers. So first you take 100 microliters of phage buffer mixed with phage, and you take 10 microliters out of it and put it into another container, and do so repeatedly until you reach a concentration of 10 raised to the power minus 5.
And then after that, we were supposed to make high tidal lysate, but due to setbacks caused by contamination, we were unable to. And we did, however, manage to analyze our phage using electron microscopy. And the ultimate goal for this class is to sequence and record the genetic code of the phage. Your turn.
Collection. We collected samples from across campus from various sources and also more exotic places.
Locations. Like, I collected some from my church group on campus, and then buy some apartments and right in the garden outside my dorm. And then over that break, I got some samples from Lake Michigan, which I had high hopes for, but I was disappointed.
We collected samples from various soil types, including dry soil and moist soil, but it just turned out that we couldn't find that phage which infects the kind of bacteria that was given to us.
Okay, so our soil samples were taken from another team, and they were collected on September 10th, 2015 at 2:01 p.m. The location was 40.42 north by -86.92 east at a depth of 4 centimeters. Overall, the soil was relatively damp and it was in an urban area and fairly close to foot traffic, so there may have been some contamination from people's shoes.
Which is a good thing.
Yeah. And it was just fairly level soil, and there was a lot of mulch, clay, and mushrooms in the area.
Right. Future work. If we continue on this project, we would first work to create the high titer lysate, which we never got to because of issues which we faced. And after creating the high titer lysate, our ultimate goal is to study the DNA of our phage. So we would study the DNA and possibly even work on making sense of the DNA.
And then we may improve our aseptic technique, as the previously mentioned contamination. And we may access the data in future research projects. Who knows?
Okay, let me introduce you to our phage, Larry. Larry is a interesting phage. It has a medium-sized tail with stripes on it and a translucent morphology.
And now to the setbacks. Now onto the setbacks. Originally, we were unable to isolate any phage from the soil samples, and were forced to use another group's sample. And then several of our plates got contaminated, and because of this, we had to re-streak earlier generations. This happened twice.
Okay, I once stuck my thumb in a plate, and we destroyed the agar when we were creating the MTL. We poured the... What did we do? Oh, we stuck the filter right into the agar and destroyed it.
And I once reached my hand across the flame and nearly burned myself. That was fun. Now, for troubleshooting, we use control plates to compare against the infected plates, and we did decontamination checks, which were unsuccessful, and we compared methods with trusted sources like the lab videos and instructional documents, just whatever we had on hand.
And the other resources available on Blackboard.
Yeah.
Critical decisions we made.
Well, the most critical decision we made was the decision to attend class, and after that, important decisions were deciding where to collect the samples and whether to use water or soil samples. Like, water is easier to filter, but...
Deciding which flakes to streak was also an important decision we had to make, and also we had to decide how to proceed when there was a contamination. We decided to go on streaking despite the fact that we did see the contamination. Maybe that was not the right choice to make, and we would probably not do that in future.
And then for convenience, our samples were all named after Greek letters, with the notable exception of Larry. And I also sanitized my laptop after every class just to be safe, like in case I bring something home, get my roommate sick.
Improvements that we could make. We should be more careful about avoiding contamination and also avoid streaking from contaminated sources. We should always keep our equipment clean and also our samples closer to the flame while we're working on it. We should better sanitize our hands, we should sanitize our desks better, and improve handling of lab equipment.
And my advice for any future students in this class would be to collect as many samples as possible. You can never have too many. And you should also be very careful to avoid contamination. I also learned a couple interesting facts that parafilm is fun, and I would not recommend drinking the agar. It probably doesn't taste good.
Eli knows this firsthand.
And don't allow the agar to solidify. That'll just ruin your experiment.
Always check the agar for contamination.
And don't trust E. And also, don't lift the vortexers. They're a lot heavier than they look, and you'll probably get a hernia.
Results. The phages within the soil samples which collected were unsuccessful in infecting the mycobacteria. While streaking, a contaminant was introduced at some point, which we never removed completely and does show itself up every now and then.
And serial dilutions yielded the most phage at a concentration of 10 to the negative 2. And electron microscopy showed us the general appearance of our phage.
Conclusions.
Based on our lack of success in growing phages, our soil samples contained no mycobacterial phages. They very well may have contained other types of phages, but we weren't testing for them. So
we also conclude that we should be better for practicing aseptic technique to avoid contaminations.
And yeah, because that prevented us from completing the experiment and sequencing the phage DNA. The contamination was somehow introduced at subject tau.